is 20. The sequence of them varies, the number of each type varies, but you're still starting with the same box of building blocks. And the covalent bonds between the different types are different too. So amino acids are linked together through a kind of bond called a peptide bond, where the amino group of one links with the carboxylic acid of another to make a peptide bond. DNA and RNA, you take nucleotides, you link them through what's called a phosphodiester bond. And sugars like glucose and fructose can be linked together through what are called glycosidic bonds. So here is a glycosidic bond, here's glucose, and here's glucose appearing in part of a larger, let's say, starch molecule. So it's a kind of ether linkage, but that's a glycosidic bond, a covalent bond, strong, a few hundred kilojoules per mole necessary to break that. This is a very stable structure because it's a strong covalent bond. And you can just continue adding more and more and more. You can make your starch molecule, in theory, as big as you want by just adding more. Or sometimes by putting branches in. With DNA, this is how you'd build up a chromosome with, molecular weight of 20 million. You start with a building block like this, adenosine monophosphate. It's got a phosphate, a sugar. Here it is appearing in a strand of DNA where the phosphate of another nucleotide is linked to the sugar here at the number 3 position. And the phosphate up here is linked to the number 3 position of that sugar on the next guy. So this has now been embedded in a long DNA polymer. But if you want to lengthen it, you just keep adding more.